series. And before we get started, I would like to ask if there's anyone that would like to pray us in. And if you do, just put your hand up or get our attention. Who would like to pray us in?
I was going to ask you about that. He's okay.
All right, going once. Who would like to pray us in?
I'll pray if no one else will. I'll
Who's
pray.
that?
Reggie Lyles.
Reggie Lyles. Okay, go ahead. Hold on a second, Reggie. Let me mute everyone first. We're going to mute all. Okay. Okay, Reggie, please go ahead, please.
Heavenly Father, we thank you for the opportunity to be in community tonight, to study of your world that you created. We give you all praise and honor for allowing us to exist in it. We thank you for giving us intelligence and the desire to learn of ourselves, the world, and of you. So God, we ask that you bless the professor that you created, that you gave such talents to, that's been obedient to his vocation, oh Lord. Bless him tonight. Father God, we ask that you would touch the connections and the technology, that we will have a clear communication. And Lord, we ask that we learn something, that we could be better useful in your kingdom building. Bless everyone under the sound of my voice, their families, their friends, their children, their significant others. Bless those who have suffered in the pandemic and those who have suffered in the conflagrations around our Bay Area. And bless those who are suffering from the hurricanes down in Texas and Louisiana. Lord, this is my prayer in the name of Jesus the Christ. Amen.
Amen. Amen. Thank you, Reggie. I appreciate that. Well, I want to welcome everyone. I'm Ronald Baptiste, Brother to Brother. Brother to Brother's theme is Psalms 133, and that says, how wonderful and how pleasant it is for brethren to dwell together in unity. Brother to Brother is a 501c3 nonprofit organization. It's been in existence for over 20 years now, and we are absolutely humbled and proud to present tonight our continued speaker series called Black People in the Biblical Lands of Kush and Egypt and Their Contributions to the World. It's been fantastic series. We are in week number 5, August 27th, and the theme tonight is mathematics, and I'm really looking forward to it. Our professor and our teacher here tonight is Professor Manu Ampim. Here's his bio. I'm just going to read it briefly. Professor Manu Ampim is the director of advancing the research and is a noted historian and scholar specializing in Africana Studies. He has conducted primary research in nearly 24 countries over the past 30 years and is the author of numerous scholarly articles and several books, including his latest work, A History of African Civilizations. Professor Ampim is also a tenured professor at Contra Costa College and chair of the History, Anthropology, and Geography department. In addition, he has facilitated various workshops throughout North America and has worked with several renowned scholars. It's been a great presentation so far this week. I'm sure all of you that have attended agree, and we're in the last 2 weeks. This week again, mathematics, and next week, architecture. So without further ado, let's welcome Professor Manu Ampim. All right.
All right. Thank you, Brother Ronald. I appreciate it. And good evenings to the brothers and sisters. I'm glad to be with you again on another Thursday. I think Zoom, the connection is kind of struggling a little bit. So the PowerPoint presentations is probably best if most of you, if you turn off your videos, because I think the bandwidth is struggling today because most of what I'm hearing is kind of choppy for most people. So I think I think that'll work. And then once I finish the PowerPoint, then we won't need as much bandwidth because I think otherwise we might have some sound issue. So thank you, I appreciate it. Well, I'm excited to talk about the African contributions to humanity because it's quite obvious that what happens most times is that people, when they think about Africa, they think about game parks and animals or something wild and unusual, like people in the village, somebody got AIDS or some wild story. But for me, I don't conjure up those kind of negative ideas and views. I think about Africa at its apex, and that's what drives me every day. And that's why I'm always excited about going to do the field work because there's nothing more important than going to the sites and sources themselves. So I have the pleasure to share with you some of the mathematical insight and knowledge that Africans have given to the world. And, we have people that teach math that have degrees, they have master's degrees, PhD degrees, and they don't know any of this. I mean, literally, they're absolutely a zero when it comes to knowledge about African contributions. So, obviously the call is one who learns, they teach, and that's really what it's about for us. So as usual, I'll give an overview and give some foundation and some insight about the topic, and then we'll open it up for discussion. And so I will share my slides, and then we'll go from there. And as Brother Reggie said, that we hope that the Creator will make sure that our connection stays in good shape tonight, so we can clearly present the case as we move forward. So this will come up in a minute, but as you know, the series is Black People in the Biblical Lands of Kush and Egypt, or really Kemet, and their contributions to the world. And so let's move forward with our task tonight. And one of the things that's a challenge is that a large number of Black folks, they say the same thing. It's a phrase that is extraordinary to me. You know what it is? I'm not good in math. They say it all. I say they, not we. I don't identify with that kind of sentiment. And I say, whatever you think, you're right. It's about controlling the 6 inches between your ears. And for me, it's not about giving away my ability. And so it's all about, mathematics. Mathematics is the gateway to the sciences. And so I knew that I was a good thinker. And if I can look at original evidence and make a critical assessment of artifacts and documents, and then if I can be detailed and specific in my work, I knew that I could also do well in math. So when I came back actually from doing research in the field, I began to tutor in math. No big deal, because even when I was young, I mentioned last week that I went to Ernest Ingold, and we played basketball at the boys club all the time. And so we figured out our averages. Nobody had a computer or calculator, I should say. The best calculators are 6 inches between the ears. And so we did mental math all the time. And once I remembered that, then math was simple for me at the college level and beyond, as it was when I was a young fella in the Fillmore district. Well, as you know, we're using pretty much some of my text on African civilizations, and all of the seminar topics that we've already addressed. We put in context the historical timeline. We dealt with the writing and ethical values. The third week, we dealt with social organization and the list of female rulers. And then last week, we dealt with the the classical African contributions in medicine. And so obviously tonight, we want to look at the next area, which is mathematics. And very important to really deal with math because it's the gateway to the sciences. And so I just have, a few slides to give you some visual images of what we're discussing. And again, we are looking at the Northeast African region of Kemet. And you know it is Egypt. That's Egypt, of course, is the word that the Greeks gave to this land, but it's a misnomer. It's a misrepresentation of the earlier language. Kemet meaning the black land or the land of black people. Not black land meaning the soil, but you know, when people say black Africa, they mean the part of Africa where black people reside. And that's what we mean when Kemet, when we say the black land, we mean the land of Kemet that the land was occupied by black people. So, so math, let's take a look at this here. I showed you this last week. This is the Udjat Eye or the sound eye. And you recall that this sound eye, I indicated that it's a medical symbol, but it is also, and we think that this is probably the origin of the RX symbol in pharmacy. But this same eye, the sound eye, the Udjat Eye, as it's called in the ancient language, very beautiful. Look at the beautiful jewelry, and but it's not only that. It is also a. You see the beautiful eye. They call it the Udjat Eye or the Eye of Heru. The Greeks changed it to Horus. But it's not just a symbol, and it's not only medicine, but it's also a mathematical symbol. So each part of the eye represents a fraction, as you can see, and so it's a mathematical symbol a lot of times, as much as it is presented as a medical symbol. And you see it in a lot of jewelry and other artifacts, and it's made to exquisite beauty, as you can see. Look how beautiful the jewelry is, and we're looking at an image that is at least 35 or close to 3,500 years ago. So math was everywhere because they used math in the same way any advanced society would use math, for measurements, to measure the land, to make calculations. And they were always using math. They were and masters of it as well. And that's why they were created. That's why they created the first accurate solar calendar in the history of humanity. So the modern calendar that we're using actually goes all the way back to Kemet. And that's a whole nother story to look at the calculations there, where you have a calendar that goes back literally thousands and thousands of years. But we won't really discuss that today. But the writing system, or the numeric system is not very difficult really to figure out. You can see here on the left, you know, one stroke here equals 1, and this arch is 10, this coiled rope is 100, the lotus flower 1,000, and that's how you can see the pointed finger, and a tadpole is 100,000, and then a million. You know, a deified person, a man, a god with arms raised equals 1,000,000. And so this is how they were. So when you see the inscriptions, the proper name for the inscription, by the way, is called Medu Neter. The Greeks called it hieroglyphs, but Medu Neter means divine language or divine speech or holy writing. And that's what they call their language, Medu Neter. And so this is Medu Neter inscription, so-called hieroglyph. And you can see how it looks here, same as the left. But then if you see how it's actually put together as they are counting in the numeric system, this here, I guess you would see it as like I guess it looks almost like a Pac-Man symbol to you. You see that? So you have 2 here, so it's 1,000. This would be 2,000. Then you literally count, and there's 6 strokes, so 2006. They're also able to do fractions as well, and so you got 1/4, and you see how they were able to use fractions. And so the system is not really difficult to figure out at all, but it is you know, very complicated and complicated understanding of math, and they tried to simplify it. This is why there's a number of different mathematical problems. They were able to take complex problems, and then they never show their work, but they do have the correct answers. Here is a royal cubit. This is these are examples of royal cubits, and the royal cubits. I think a lot of times we hear about a cubit. So there's a regular cubit, which is about 18 inches or something like that, and then there's the royal cubit. This is the royal cubit, so it's a little bit longer. So the regular cubit is about 18 inches or so, and you know, it's got to be practical. So for them, there was no you know, some metal tape measure or like that. So what they used was these. They would normally be made out of stone or metal. They operated just like rulers. I think you see some of the lines here. But the cubit, the 18 inches, it would be from the elbow. So if you right now just see where your elbow is and kind of hold your elbow, your arm up or something or out, and measure from your elbow all the way to the tip of your middle finger. From the elbow to the tip of the middle finger, and obviously we're different. But for them, that would be roughly around 18 inches or so. And that would be a cubit. But the royal cubit, what you see here is a little bit more. The royal cubit is about 20 inches, 20.6 inches, right around there, 20.64 to be exact. And you see some of the beautiful inscriptions. But this was, excuse me, but this was a ruler. And that's what they used. So it was a measuring tool to make sure things were accurate, were straight, and were measured correctly. So they used math on a regular basis. And you know what's interesting about ancient Africans? They were always close to nature. So you don't find anything. You don't find a bed, a chair, or anything else, or even daily life. Almost always have some images that on of something, animal, plant, and you can see here, for example, see animals above going across and below. And but this was a measuring tool, and these are some of the artifacts. So the royal cubit, again, about 20.64 inches, right around there. It could be a little bit more, sometimes 20.8, but they were exact. These were exact mathematicians, so they weren't guessing at all. The stonemasons would use these royal cubits on monuments that were meant to last for eternity, and the angles were exact. The angles were perfect. And when you look at these angles with stones and monuments, you say, what? So even the mathematicians tremble to see that people were that exact. And they would be exact when they were carving things, even though many people would not even see them. You know, you would have a coffin, for example, in a tomb that is not even meant to be seen, but yet carved to perfection. And I tell you what, when people go and see these things in either a museum or they get a chance to go to Cubit, then it'll be hard to argue that the way that they were able to have a true angle, a true 90-degree angle, for example, you would say that has to be a laser finish. How did they take it in tools and carve granite to that kind of perfection? But that's what the standard was. The standard was greatness, because they were always building and carving and creating for eternity. And that's what you see here. You see, you know, these measuring tools. And the oldest measuring tools go back actually to about the 18th dynasty. So we're talking again about 30, 35, 33, 34, 3,500 years ago. That's the time period. Here's a royal cubit. You see these images here. You see the nice glyphs. This is the same thing that you would see with a ruler. So just think about a ruler. That's what it is. It's a measuring tool, and they were very exact when they were measuring. So you know, people say, "Oh my God, they did all of that way back then," to make it seem way back then, meaning that they weren't able to achieve measurements and angles and correct angles and true angles back then. What do you mean back then? No, it's just very exact. You all will remember this throne too. You see the throne, you know, representing Aset and her husband Asar. That's what that represents. But the royal cubit is one of the basis of measurements for them. Also, look at this leveler. So that, you know, it's like a plumb bob, and so it's really to measure this, to make sure everything is level. And this is why it's amazing how they were able to take any kind of stone. And then there's a lot of metal tools. So they were able to smelt iron as well. And they had this iron tools as well that were used. But this is like a, you know, pump out to make sure everything was level. And you find this in a few museums. It's not always common, but you do see the actual artifacts from different museums and make sure everything is straight and level. And then there are documents. Now notice the name of this. This is pretty similar to what we said about the medicine. Here you have the so-called Moscow mathematical papyrus. And notice the time period. It's about 3,850 years ago, or 1850 BCE, before the Common Era. And of course, I'm mentioning the name because of the problem. But why, somebody stole an artifact, the papyrus from the continent, from Africa, put it in Moscow, and then name it after the new location where it's at. Well, this is called theft. This is a misrepresentation. Here you have African contributions to the world in math. Here they're calculating the volume of the cone or a pyramid, and somebody else is getting credit because it's in a Western or a European museum. But you have the calculations. This papyrus doesn't survive so well, and so and that's what happens a lot of times. They're old, and then you have, but they would survive even though they're old, but they've gone through a lot of hands. You have grave robbers, tomb robbers, sellers, buyers, dealers. It goes from one location to the next, and then by the time it gets to a museum collection, things are in tatters. They're shredded. Things are damaged. Even though when they were found, or should I say taken, they were in great shape. So this is an important document because of the calculations, advanced calculations that were being used. So this is one important mathematical document, but I want to really spend time on this one. This is a crucial and critical mathematical document here. This is one of the, actually is the most important of all of the mathematical papyrus that survive. And it's the wrong name, but as you see, then this is a book here, the Rhine Mathematical Papyrus, and this is the title of the cover of a book. So this here, the importance of this is that it is the oldest complete mathematical document in the history of the world. Not one of, but is the single oldest mathematical textbook in the history of humanity. Here it is right here. So it's not myth, it's not legend, it's not fable. It is an actual physical document. And that's part of the document that you see on the cover of the book. And now what's interesting about this is about 1600, and I believe I mentioned this last week, around that time of the period when they were building many temples, they also were rewriting and transcribing old papyrus. They were transcribing papyrus text or text on papyrus from one papyrus to another. So they were copying text. This was a period that there was a lot of text copied from much older text because the older texts were in decay. So what we know about this advanced mathematical document is that around 1600 or so, it was being copied from a much older document that was in decay. And as you already can imagine, there were no scanners, there were no photocopy machines, no cameras. So the scribes, the writers had to copy documents by hand from one papyrus to the next, and that's what is happening here. So we know that this 1600 BCE document, or 3,600-year-old document, is the knowledge of it is much older than 1600 because the scribe had to copy it. Now what happened here, very similar, is that the man A.H. Rhine, he purchased this papyrus in the 1850s. So he purchased it 3,400 years after it had already been copied. But yet people want to call it the Rhine papyrus. But the good thing about this particular document, in terms of the history of this document, we actually know, it's rare, but in this case, we actually know the name of the scribe. We know the name of the African scribe, the African writer, the African brother who transcribed this from an earlier document. And his name is Ahmose. So this should not be called the Rhine papyrus. This should be called by the name of the scribe that we know copied it. and his name is Ahmose. And what Ahmose is saying in this document is that he never said he created the knowledge. What he said was that he was given instructions to copy this document from an older document, and he writes his name in order to do what? Not claim ownership. He writes the document, he writes his name in order to say that he is faithfully copied the knowledge from the older document to the new document. I think somebody has their mic on and it's a little bit loud. If you don't mind, if you can mic yourself, please, or mute. Thank you. All right, so
how are you?
I think that's you, Shirley McDonald, and your mic.
Yeah, I took care of it, Manu. I got it.
Okay, thank you. All right, so now what's important about this document here is that this is as I said, the oldest complete mathematical document in the history of humanity. So what does it contain? Well, it contains 87 advanced mathematical problems in trigonometry, geometry, calculus, arithmetic without one single mathematical error. Not one, 87 on this document. It's a crucial document. So let's take a look at this all important document, which clearly indicates the advanced knowledge that Africans had. So of course, let's do what with the name? Well, we have only one thing to do with the name, and that is what? Get rid of it. It shouldn't be there. So let's get rid of this outrageous name. We're not going to let them steal our contributions. So now think about what I mentioned a minute ago. So what should we call this document? What should we call it? Well,
Ahmose document.
Ahmose document.
Yes, Ahmose. Absolutely, you're right. It's the Ahmose document, and no other name will work. We know who is described. He says he transcribed it from an older document, so we give the brother, the African, the credit. Now notice that again, you have the two regular or common colors of red and black. So red represents a different or a new mathematical problem. In this case, the red represents the title of this document. And now look how important math is in terms of how they saw math and how they presented it. So this is the beginning of the document. You can see why documents would have to be copied from the older to the newer in order to preserve it. So, paper decay. From paper we get papyrus. But take a look at this. This is the title. That's what you see here. This is the actual title. This is the opening description of the document that has these 87 advanced mathematical problems. And Ahmose writes or copies this. He said, this is an accurate method of counting for grasping the meaning of things and knowing everything that is, all mysteries and secrets. Ooh-wee. I mean, that's a whole lot of insight. It's not regular math. It's math at another level. He's talking about an accurate method for knowing everything, all mysteries and secrets. So they never separated math from a deep level of knowledge about all things that need to be known. It's about mathematics and having a calculated view of things. And so that's the title that you see here. So let's take a look at some of it and let's destroy one of the most prevailing myths in the Western world. And here in California, by the 10th grade, every 10th grader is supposed to learn geometry. And they learn one of the most outrageous myths, that the so-called Pythagorean theorem, that a squared plus b squared equals c squared. Remember the time frame that I just mentioned, about 1600 years ago is when Ahmose transferred the knowledge to the document. Oh, by the way, let me also say that in case you want to know, or even if you don't want to know, I want you to know that that document, the Ahmose Papyrus, is in the British Museum. It's in London. So a person can go right upstairs to the second floor, unless they've moved it in the last year or two, second floor, and you will see the great document right there. All right, so this is a myth. Pythagoras. Who was Pythagoras? Well, he was, now take a look at the chronology. How could it be the Pythagorean theorem, but a squared plus b squared equals c squared? This is attributed to Pythagoras. He lived about 1,000 years after the Ahmose Papyrus was created. So what else do we know about Pythagoras and why he could not have created the knowledge? Not only is the papyrus more than 1,000 years older than him, but there's nobody that taught geometry in Greece. Where are the teachers? You don't learn advanced mathematical knowledge just through osmosis. There were no Greek schools of geometry, no traditions of geometry, no books. No one knew anything. There's no evidence that Pythagoras or anybody in Greece knew anything about geometry and advanced level of math. Because remember, documentation beats conversation every day of the week. And there's not a shred of evidence that he knew anything. In fact, what we do know is that not only is Pythagoras a zero, meaning he knew nothing about geometry and advanced math when he was in Europe, in Greece. So where did he get any association with the knowledge? The man actually, Pythagoras, he actually, when this decides to come up, he actually studied 22 years in Cubit. He was a slow learner, by the way, so it took him quite a while. He wasn't no fast learner. So like those that can get their degrees in 4 and 5 and 6 years, no, 22 years, 2 decades for him. Well, actually more than 2 decades. The records inform us that Pythagoras, knowing nothing, goes to Cubit, learns under the priest, learns under the mathematicians, and then returns to Greece 22 years later, teaching a subject that he didn't know when he left. And the Greeks themselves document this. So under no circumstances should people be talking about the Pythagorean theorem. So let's take a look at the evidence from the papyrus itself. Here it is. So you got the evidence here. Notice how neat and orderly. Notice how this is set up as a papyrus. We already know that the red represents different problems. We already said 87. This is that formula: a squared plus b squared equals c squared. There's no debate. There's no doubt. There's no speculation needed. The evidence is quite clear. And yet people still fabricate a European contribution in the field of geometry that does not exist. And so it's here. It's clear. You got different problems dealing with this. And so Pythagoras, you know, clearly he's been quite overrated, and we want to do away with that. So as I mentioned, this is more than 1,000 years before even his mama knew him. Even his mama didn't know him. And this is why we cannot allow this kind of misrepresentation to take place. We got Black children all over, Black students all over the country. I'm not good in math. You know what? Whatever you think, you're right. So no, it's not about not being good in math. Put the calculator down. The best calculators are 6 inches between your ears. And you know, and too often what I've seen in schools, even in independent Black schools, it's the same thing, that you don't have to tell the youth that math is not important. You just show them that it's not important by doing what? Spending all of the time on drawing and coloring and singing. Okay, all of that has its value in PE, and just minimize the time in math. And then show them by demonstrating that we don't need to spend that much time on it. And I've actually seen teachers do that by minimizing. And so by the time I see them in college, it's a whole lot of work that has to be done, you know. So, but nevertheless, this clearly documents this important and unmistakable African contribution. So we need to call it what? The Ahmose theorem.
Ahmose theorem.
It makes logical sense to anybody that can see the evidence. There's no debate. There's no dispute. And you know what's interesting about it is that the mainstream Egyptologists, they have a problem. They say, yeah, well, these problems are correct. They were using the formulas, but the scribe must have had problems with these. What do you mean the scribe had problems? Every single one of the answers are correct. You having problems with some of these, so don't put that on the African. That's your issue. And so, so it shouldn't be the Pythagorean theorem, it's the Ahmose theorem, and the evidence is pretty straightforward. So again, it's in the British Museum in London, and there's not much debate. And then we can look at the sources where the Greeks themselves write and document that Pythagoras didn't know very much, spent 22 years in Cubit as a slow learner. He was in one of those special ed programs. And then after he finished his special ed program, he goes back to Greece, and they wrote about it. So there's not any debate about this man's learning under the African mathematicians and priests. So So all 10th graders should learn something new, and they're not going to learn something new unless we teach the teachers. So also in terms of math, if you look at mathematics, we have the buildings, and next week we'll look at this in more detail when we look at architecture and the building of these pyramids. But these great pyramids in Giza, built for kings Khufu, Khafre, and then the smaller one of the big three is built for the king Menkaura. And these are tremendous monuments. And not only is it architecture at an extraordinary level, but of course it's math. It's mathematics they were applying math at such a sophisticated level that is absolutely stunning. So to give you an idea of the size of these wonders of the world, these are people here in the box. You say, I don't really see them. I know, that's my point. They're insignificant. And then these, trust me, these are people. And look how small they are. And these are people. And so compare these tiny people to the most enduring monuments in the world. So the one built for Khufu, about 46, almost 4,700 story skyscraper, about 481 feet. The one built for Khafre is closer, so it looks taller, but this is about 471 feet. And then 218. But anyway, what I want to point out to you here is look at the side here. You see that this is a perfect triangle. This is a perfect triangle made out of stone, out of limestone. Some of the limestone blocks are, on average, they're 2.5 tons, 2.5 ton stone. And on the inside of these monuments, we have 50 ton stones and 50 ton stones and more. But the mathematics is absolutely exquisite. So like, for example, take a look at what happens here when planes fly above and we're able to take a look at the aerial view. Now you can see the mathematics that is demonstrated. It is math that's applied. And he not only applied it in everyday life, the Cubit and all that, but they applied it to monuments that still confound the world. Now these are 4 images of the same Great Pyramid. This is the one that you saw to the right, built for Khufu, the Great Pyramid built in the 4th dynasty. So it doesn't matter what angle you look at. If you look at this one, it's a perfect square. This too, in the shade, is a perfect square. Then you have different angles that you can see here. This is mathematics at an extraordinary level. Let's take a look at this one. If you take a look at this this angle here, notice that you have how many sides? You got one side, a second side, a third, and then on the back is a 4th side. And so, and they all are equal angles. So it's like, wow. And how long did it take to build such a monument? Well, we're told in the record that it took about 20 years, built without slave labor, built with high level mathematics. You got African scientists, African astronomers, who were able to put together the monument to help them tell time. So you can tell the time of the day based on, and the seasons based on how the sun casts a shadow on these monuments. And so, okay, so let me give you some orientation here. Okay, so if you take a look at the bottom left, this is a huge boat. We'll talk about it next week, and you can see it over here as well. So this here, this side is this is the south. This is the south side here. So this is south. Obviously, this would be east. This is the west side, and then this would be north. So think about this image here, and think about the shadow. So what time of day, roughly, would it be? Yeah, about what time of day would you say? We're looking at it from the south side. Would it be early morning, midday? Would it be late in the evening?
Afternoon.
Maybe so. That's probably pretty good. It's probably afternoon. So where's the sun at in this image? The sun would be
in the west.
Okay, very good. So the sun rises in the east and it sets in the west. So we know the sun is here to the west and it's casting a shadow. And you know, it's interesting because when it's 12 noon, the sun overhead, no shadow. Very interesting. So if we can figure that out, of course, they were able to figure that out over the course of many, many, many generations. And then when the planes fly above, you can get, so this is the pyramid here, this one, and this is the one in the middle, but this is how we're able to get the aerial views to really see the sophisticated monuments that represent a fantastic, a tremendous level of mathematical knowledge. They were able to apply correct measurements in not only, smaller artifacts, but major, massive artifacts. And so take a look at this, for example. This is an aerial view. And these are the 3 largest pyramids. And I didn't mention that the smaller pyramids were for family members. But take a look at these 3 massive monuments. And take a look at the perfect angles. Now, can we all agree that this is a perfect triangle? There's no dispute, no debate. It's clear. But it's an aerial view hundreds of feet in the air. And again, let's take a look. We got a perfect triangle, a second one, a third perfect triangle, and a fourth. So the mathematicians that are with us, if we have 4 equilateral triangles, what does that give us? If you have 4 equilateral triangles, that means that we have what? A perfect
octagon?
Not quite. The triangle.
Square.
Ah, yes, a square. Very good.
Yeah.
All right. So 4 equilateral triangles represent a perfect square.
Yeah.
There it is.
Oh, at the base he's talking about.
Yes. Yeah, the base. I'm sorry. Yeah, I'm talking about the base. Yeah, I'm talking about the base. Okay, so maybe you didn't.
That's where you threw me off.
Okay, all right. Okay, yeah, I'm talking about the base. So the base, yeah, I should have been clear. All right, so the base of each of these represents a perfect square. No debate, no discussion. So 4 equilateral. So this is the kind of sophisticated mathematical knowledge that they're demonstrating, and we can go into even more details. But I'm excited about those papyrus because of papyri. But these monuments are what we will discuss in great detail next week. And before I end, let me go back to the Ahmose papyrus and show you and tell you something else about this great document. Okay, so this document is, we know it's in the British Museum, and we got the title, we know who it relates to. And the front side of the document, there's the 87 problems. There's the 87 advanced mathematical problems. That's on the front. Now on the back side, one of the things I didn't mention, on the back side, there's a very elaborate mathematical formula that has to be broken down and simplified. So on the back side of the Ahmose papyrus, there is the ancient scribe and chemist broke down this formula into 49 kind of simple. They broke it down into 49 kind of simple expressions of a very sophisticated formula. Anyway, they broke it down into smaller elements, and the scribe broke it down into 49 elements, and out of a possibility of 22,295 possibilities. So out of 22,295 possibilities, the scribe broke it down into the 49 most simplest. And so there was an experiment done in 1967, and it was a computer, and it took the computer roughly about 5 hours to take that formula on the other side of this and break down this elaborate formula. And it took the computer about 5 hours, and the computer came up with the same 49 simple expressions that the scribe had came up with, or Ahmose had came up with thousands of years later. And people were fascinated by this. And because it's so advanced, you always have detractors. So there are a lot of people, mainstream Egyptologists and mathematicians, they try to detract from this because if they admit that this level of knowledge not only existed, but the scribes were not guessing, this was highly theoretical math, then clearly it shows that Africans were literally thousands of years, millennia ahead of those in the West. And so we have to give respect to Ahmose because of him copying this, and in this case, subscribing his name to it, you know, his signature to let us know who he was, so that now we have a name to put with this great document. So that's what I wanted to, you know, share with you tonight, that this kind of mathematics, it really needs to be more widely known, more widely spread, because it's unduplicatable. It's unduplicatable. Others have not been able to duplicate this level of mathematical precision. And you've seen it here, that is demonstrated in graphic and colossal form in front of us. So, so thank you, brothers and sisters. So you now are now official experts at the African contribution in mathematics to the world. All right, thank you very much, and we will now open it up.
Fantastic, fantastic. Okay, so if you have a question, there's two ways you can ask it. One is you can put it in the chat box if you want to, or you can just put your hand up and unmute yourself and ask it yourself. So either one. Why don't we see, Lonnie Wilson, could you ask Manu to discuss the fact regarding the straight line that extends from the tip of the Great Pyramid of Giza to a point in space that occurs only every 1,000 years, please? Manu?
Okay, so let me, okay, so that question, we will deal with the Orion star system next week. Let me just show what I believe sister's asking here. And I think your videos might be okay now. I just wanted to make sure that at least during the formal presentation, you can hear me and see the slides. I think we might be okay now to turn on the videos. Okay, wait a minute. So I think what you're referring to is, let's see. Oh, you know what? I don't know if I put what I wanted to show you, but let's try this one. Okay, you might be, okay, you see these pyramids here. This is Khufu pyramid, Khafre, and then Menkaure. If I, and we'll show you next week, if you drew a straight line here, if you drew a straight line from the apex here to the middle pyramid, and then to the smaller pyramid, it's going to be off a little bit. It doesn't really dissect here. It's a little bit off. And what the idea is that these pyramids in Giza, they align with the Orion star system, because if you look at the Orion belt, the Orion has two huge stars that kind of resemble the pyramids, and they're in a line. And there's a large star, but it's not really on the same line. It's a little bit off. So the Orion star system has been assumed for now some years, based on the research of several people, to show that this third pyramid being a little bit off is deliberate, because, you know, the idea as above, so below. And I think that's what you may be referring to. But what we can say for sure is that it is not guesswork. Guesswork is not speculation. They definitely studied the star system, and they believe that that star system, it influenced their ideas of what happens after they enter the spirit world, because it was all about ascension. And there's actual images of people riding kind of a serpent that they've turned into good. They're riding a serpent towards the stars. And not only that, but the whole calendar system is based on that star system as well. So it is not a leap at all to say that these are in line with the Orion star system, which we will cover next week. I believe that's what you might be referring to, but this is offline on purpose. And that's the idea, because that's how the Orion star system is. You can see it from photographs of the Orion. So that's what's been documented.
Fantastic, fantastic. Okay, so we got a few hands up. We're gonna go after Daniels, then we're gonna go Leo Basil after that, okay? So
Okay.
after, why don't you unmute yourself and go for it?
All right. Professor, we have the pyramids in Egypt, and we also have pyramids in South America. Now I've been told under the assumption that the sun rises on one and sits on the other. Is there any truth to that? Or do you know anything about that?
Well, rise and sets is more there is a orientation, and we'll cover it next week. There's an orientation, like in Kemet, the orientation of every pyramid is on the north-south axis.
Okay.
So it's not necessarily the sun that they were focusing on. You have like there's actual in the pyramids, and there's actual what do I want to call it? It's like you can see in the galleries, you can actually, there's like
the stars,
a way you can actually see the star system. Yeah, so it's like they're lining according to the star system. And
Okay.
so they call it the Sopdek star. So the Sopdek star, or people call it the Sirius star, that's how they were able to set their calendars. And
Okay.
so when that star appeared, so it's more based on stars, but there is, I believe, a connection between the pyramids in Giza and the ones in Mexico.
Okay.
In Mexico, because there's a lot of similarities that I don't think are happenstance or by chance at all. So I actually will show that next week, where you can see the whole layout of the pyramid field in Giza, and then you see the pyramid field in a place called Teotihuacan, and it's I don't think it's a coincidence at all. And
Okay.
because where else in the world do you see pyramid field very similar with colossal statues, with hieroglyphic writing? It's too many similarities just to be a coincidence. So
Yeah.
we will cover that.
Okay. Thank you.
All right, fantastic. Leo,
Sure.
go ahead, Leo.
Yes, Professor, I'm one of those who does not understand math, so forgive my question if it doesn't make sense.
All right.
But I'm looking at 4 different areas. I'm looking at mathematics, what you're talking about, but how does the Kemetic and Kushite understanding of astronomy, astrology, mathematics, but geometry, what order did they master those areas? Did they come up with their understanding of looking at the stars? Because I know the Orion belt and everything plays a big role in their, I guess it is astronomy.
Yeah, they seem to have mastered these areas. In fact, it was the Greeks, the Greek writer Lucian. The Greek writer Lucian, he specifically gave credit to the ancient Africans in Kush. He said they were the ones that invented astrology, or the study of the stars. He said they invented astronomy, or the study of the planets. And they actually gave credit to them. We already know about Diodorus. He never claimed to be a mathematician of the highest order teaching geometry. He simply learned from Africans and went back to start teaching. But in these areas, the Africans were quite advanced in all of them. And with geometry, for them, it was really to be able to make calculations for to see what the area of a land was, so they can create taxes, a tax structure for astrology and astronomy. It helps them to be able to create the first accurate solar calendar in the history of the world. And then of course they had a lunar calendar as well. So for them, they looked at all of these things, and they were very keen on making these kind of observations. This is why they created that first solar calendar more than 6,200 years ago. And so it seems to be no field that they didn't demonstrate advanced knowledge. And you see it in the monuments, you see it in the documents, you see it where foreigners are giving them credit. But those measuring rods and measuring rods helped them, but their observations were very keen. And you not only see them understanding astrology and astronomy with the building of monuments, but you see it inside of coffins as well. You'll see the goddess Nut stretched over a coffin, and you'll see the stars represented in her body, literally represented in her body. You see inside of tombs, you see the tombs painted with blue representing the sky, and then there is yellow representing stars. So inside of tombs, they make it almost like a mini universe. And not only that, but you can see all of the star systems. Actually, you know what? Let me think here. I have a slide to show you. Yeah, there is the let me think for 1 second. There is I actually don't have it in this slide. Let me think where I can show you. But there is there's the first astrological complete zodiac that was in Kemet, but it was taken to the Louvre Museum in Paris. And you see all of the signs of the zodiac. You see that, you know, that they are presenting the zodiac within the stars and the whole heavenly body there. But the advanced knowledge of astrology, astronomy is absolutely on the other side of greatness, because there's nobody was at that level to be able to understand the heavens with that kind of detail. So we're talking about not only theoretical math, but years and decades and centuries of very astute observation. So like, for example, with the Sopdek star, let me put that in the chat, but the Sopdek star, or the Sirius star, whenever that appeared, that would represent the new year. So the new year would always be like August 1st or August 2nd. And it's interesting because the Sopdek star, or the Sirius star, as people call it, it always would arise at the same time every year, and they were able to make that observation. So when that star arose and appeared, I should say, when it appeared, it's the same time that the Nile River overflowed. So New Year's Day was always a simultaneous event when the Nile overflowed and that star, the Sopdek or the Sirius star appeared, and that would represent their New Year's Day. And so that to them, that was a joyous occasion, because as a farming country, there's nothing more important than the banks of the Nile overflowing to irrigate the land. And so all of that is full of details of knowledge of astrology and astronomy. And then the monuments that we have and those measuring rods, particularly the Royal Cubit, we see that that's, you know, measurements that allowed them to master the field of geometry. But highly advanced theoretical.
Well, I understand that that the people in Kemet were great astrologers and astronomers, and that nobody that was anywhere close to them at that period of time was except over in Mesopotamia. And that the skies that we see, very seldom do we see the same skies that they were seeing, because we got all these city lights and everything. We don't realize the number of stars is up there, and the angles and the patterns that they had to work with in terms of what they were seeing on an annual basis.
No, you're right. You're right. And the Mesopotamians did okay, but they came a little bit later than the knowledge in Kemet. So, you know, sometimes people try to dismiss the earlier evidence from Kemet, but you can't, because the evidence is pretty clear going back to the Pyramid Age. And so the Mesopotamians did mathematics, but it was definitely afterwards. I'm putting this in the chat. Sopdek star is the Sirius star. And I'm trying to think now, I can find this image in the Louvre while the next person asks a question or makes a comment. I'll find, yes.
No,
Okay.
I was talking to Johnny Harrison. He's got his hand up. Johnny, I got you. Okay, go ahead, Manu. I apologize.
Oh no, I'm finished. I was just thinking where I can find this image to show you the first complete astrological zodiac in the history of humanity. It's in the Dendera Temple in Kemet, and now it's in the Louvre. So okay, but that's what. So while you the next person's up, I'll find it. I'll find it online and show you.
Thank you, Manu. Okay, so we're gonna go TK first, and then we're gonna go Johnny, and then we're gonna go Mr. Reggie Pate after that. So TK, go ahead, unmute yourself and ask your question, please.
All right. Good evening, gentlemen, and Professor. Another great, I'll call that a great performance, because along with your knowledge, you always present it in an entertaining way. You know, 'cause there's a lot of cats who can tell stuff and know stuff, but to be able to present stuff, you know, good job. My question is, the stuff you're showing us and the stuff that's available is like kind of at the tail end of what they were doing. You know, like you have the papyrus with Ahmose, what he wrote. Okay, but somebody's telling him that, he's just writing it down. So at some point there was a beginning to, and then at that point they could tell Ahmose what was going on. So I'm wondering, is there any way, and you know, you can, people can only go by what's left, basically. This is what we found, this is what somebody bought, this was somebody stole and gave it to a museum. Is there anything that was like from the beginning or the earlier parts? Because you just don't wake up out of bed and say, hey guys, let's build a pyramid that's 400 feet. You know, it has to be some beginning part. And to follow up that question, this amount of knowledge, even talking about the stars where you have to wait for a repetitive occurrence to happen. At what point did all that stuff come together? You know, was there a certain dynasty where it's just, hey, we got that, in this dynasty, they got down on science. On this dynasty, they was cooking with the astronomy. On this dynasty, we're doing the pyramids. Or was it just an accumulation of all the knowledge and the guy said, hey, let's do a pyramid. We can do this based on this. You know, it's kind of a broad, wide question, but I'm just trying to see, was it a certain period or was it an accumulation? And then at that accumulation, they said, let's do this. Let's execute with the knowledge we have.
Yeah, that's good.
Well, yeah, that's a good question, TK. So, you know, when you go back to the earliest period, to the pyramid age, and start looking at when they were building great monuments in stone, then it's like when we go back to like the third dynasty, about 2800 or so BCE, it's like the further we go back, those are the most enduring of all of the monuments. The further we go back, it's the dynasty, the sixth dynasty, and later on, they're not as they don't have the same grandeur. They don't have the same might. They don't have the same endurance. So in this case, older is better, literally, when you're dealing with these massive monuments. So we go back to the early period, high level development, and you're right, that this knowledge is not something, what we're seeing is the culmination or the manifestation of what was known much, much earlier. So that's why you don't really see a lot of experimentation. You know, rudimentary this, rudimentary that, and then finally they figured it out. Not really. You might see a change to some degree, but you know that this is a long period of high level development and experience that culminates in the production of a sophisticated surgical text or a detailed other kind of medical text with all of the kind of internal issues and details, so what we see, or even in math, this is like you're right, almost doesn't just pop up in there. He's coming from a long tradition of highly advanced theoretical math, not somebody just trying to figure it out with trial and error, not at all, high level. That's why I've said that, you know, if you look at the titles, like you look at Imhotep, the first known physician in the history of humanity, or Pei Shachet, the first known female doctor in the history of the world. You notice their titles, the director of female doctors. They have a whole tradition, a whole cadre of physicians and healers and medical practitioners. And so even with Imhotep, you know, Imhotep, or even, remember I showed you the brother with the fro, anybody remember his name? The great dentist?
Yeah.
Anybody remember his name without cheating?
Hesse Ray.
We got it, brother. Exactly. Hesse Ray. And the great, and Yeah, you know what? And remember his title, not just a dentist, but what? The chief dentist. So the first man that we see with his beautiful helical structure of the hair, he is the chief dentist. And so to your point, brother TK, it's that's what we find is that this had to be a whole organization that had already been in place long before we see. That's why I say the first known or the oldest known. That's different than saying that someone's just the first. Well, not it's the first that we know of. That's different. So that's what we can find in field after field. It is a tradition that we are seeing the manifestation of, or we're seeing the remnants of. And so you know what? And as great as Kemet is, you know what's even more extraordinary? You know what I'm even more excited about? I can see it, but we don't have all the physical evidence. Going to the south, going to Sudan, because the monuments in Sudan, they are newer, they're younger. Well, what do you mean? They're newer and younger. So what that means is that the level that we see in Sudan, the level that we can walk on and see monuments, that level is on top of a much earlier level. And that earlier level would take us to epics, long before what we're seeing. So that's what is special about it, is that we don't see just the first this or first that. We see the remnants of what had to have been a long tradition in writing, in medicine, in science, including math and astrology and astronomy, and it's all documented, no question whatsoever. So when people say it ain't so, tell them to shh, tell them to quiet down. And stop the nonsense, because it is there. And so, and you know what? And you know what? There's some people at the college that, you know, some professors that don't look like us. I said, okay, you know what? I'm going to give you these pages and take it. Let me know what happens this semester. You know, I'm not even going to challenge it. If you don't see the need to buy the book, you know what? What you should do, I'm going to give you this section. Now, if you tell me the students were excited about it, then you buy the book. That's what I'm going to tell them when they get back to me. But, you know, but the bottom line is there's a high level documentation. I think you all will be excited next week, because we'll be able to show how the math was applied in the monuments, even more than what I kind of shared today. And so I'll allow the next person to, you know, make a comment or ask a question. And I found what I wanted to show you about that first astrological zodiac. It's not my picture, because I don't want anything to mess up. I think our Zoom is shaky, so I don't want to go into different files, but I found it online. Sometimes it's easier just to find it online, you know. But anyway, that's my response.
Okay, Johnny Harrison, can you unmute yourself? There you go, Johnny.
I don't know if this was going to be discussed next week, because you kind of stated that it might. The idea of this, of the pyramids in Mexico, who brought the knowledge and who built the ones in Mexico? Was this an indigenous situation that grew up, or was this a transported idea from Africa?
Yeah, no, that, you know what, Brother Johnny, that's the age-old question right there. So let me say that what the propagandists have done when they rewrote the history of the world and wrote Africans out of our own history, when they turned history upside down and presented the Aryan history, and then they came up with the Greek Immaculate Conception, where they invented everything. So when that happened 100 or so years ago, it's called the diffusion theory. That the propagandists, they came up with the diffusion theory, arguing that all meaningful cultures, they diffuse from one central place. And of course, that central place was allegedly Europe, and that nobody had the intelligence to create anything on their own unless the mysterious, we still can't find out who they are, unless the mysterious Europeans came and taught people and start building pyramids and other monuments in Africa that they couldn't build at home. Don't disrespect us like that. Somebody's gonna leave home and start building monuments that they couldn't build at home, but they're gonna build it abroad. Really? And so this diffusion theory is how it spread, that Europe was the center of this, the center of that. You got the father of medicine, the father of geometry, and this and that, and all this other nonsense, father of democracy, and none of it has anything to do with facts. But the diffusion theory is really the idea that was promoted. And then you got the extreme diffusionist theory. So for me as a professional historian, I know that there is influence sometimes, but they're not always influence. So what I tell people is this, is that we cannot assume, and should never assume, that groups don't have the ability to make weapons, for example. We know they're going to do that on their own, or to make, or have some kind of remedies for ailments. Or every group, even a low-level group, is going to have a name for father and son. They're going to have a name for the sun and moon, even if they don't know that much about it. So no one has to go and tell somebody, oh, that's to tell them that there's a monument. Well, they can see that. They may not know the cycles of the moon and the sun. So in other words, people can develop some practices and some ideas on their own. And we have to, give that as or assume that as a fact. However, to assume that groups are isolated by themselves and not influenced by others is equally untenable, because people are always traveling. The oceans in the world are not a barrier to travel. They're a facilitator of travel. People have always used the bodies of water in the world to be able to travel. And I say that to say is that you have indigenous culture in Central America, or archaeologists and historians call it Mesoamerica. Meso means middle. And so you have that. And so you have some development by the native people in the Central American region, particularly Mexico. However, they're not isolated, they're not alone, and you have a direct, formidable, and undeniable influence of Africans who weren't just there, they were contributing on a sophisticated level. So next week I'll show you that you can look at the Olmec civilization, the first great civilization in all of the Americas, and the Olmec civilization, clearly, it's fundamentally a Native American culture. You can see their cultural elements. However, you also can see, which is also unmistakable, undeniable, a formidable, significant African presence and African influence at the kingship level 3,000 years ago. 3,000. The images don't lie.
Okay.
Fantastic.
The images do not lie. So, yes. All right. So anyway, that's what I would say.
Okay, so I want to remind everybody to look at the chat as we go. There's been some fantastic comments in there, and we're going to get to one of those questions coming up. But I want to ask Reggie Pate, go ahead and ask your question. Then I'm going to go to the chat for one, and then Ben Pope, I'm coming to you after that, okay?
Okay, I'm probably going to step on some relatives of mine's toes, but I was told when I was young, I used to hear these stories about the pyramids and the building and Hiram Abiff and the Freemasons, and I don't know what's truth and what's not. I know that they were built in Africa, they were probably built by us, and is this another European myth, or is this something that they introduced to the world, or is it not? I've always wanted to know.
I think I missed your main question.
I was told when I was younger, me and my brother, I think, are the only ones in the family that aren't Freemasons. And we were told that the pyramids were built by the Freemasons, and we'd hear stories about Hiram Abiff and the whole whatever, the Freemason thing. Were they built by the Freemasons, or these were just Masons, African Masons?
They were African stonemasons. Okay. And they're African. Yeah, so the pyramids are built by African stonemasons, and then like the Masons, the Freemasons have come along. The whole thing about well, you're right. Now you're gonna get me stepping on toes too. that so the Freemason, you got a lot of Europeans. You got there's a whole time period of what was called Egyptomania. It was this mania of going and relating and stealing everything related to Kemet and Egypt, and so hairstyles and so many things in the culture, traditions, and then you got Europeans who claim to have this secret knowledge that goes back to Kemet, and then you got a whole tradition of Freemasonry where you got people from Europe, and then that knowledge of Freemasonry from Europe. You got a Greek tradition, ancient Greeks talking about a mystery system, and then you got Europe, and then America, and it spreads from all these different groups. But if you're dealing with original Freemasonry, it is based on like Masonic knowledge, meaning stonemasons, but the way that they represented it is not authentic, it's not accurate. So I'm not saying that we shouldn't be a part of the Mason tradition, because that's us. The only thing I would say is we got to bypass the European influence and go back to the original. Just like, for example, most of us, not everybody, but most of us on the call, we're in the Bay Area. Now, if we go down the road to the now notice the name, the Rosicrucian Egyptian Museum. It's this ancient mythical order of the Rosy Cross, the Rosicrucian, ancient, and they claim, this is amazing, the Rosicrucians right down there in San Jose, they claim that their whole secret knowledge system goes all the way back to the 18th dynasty, to Thutmose III, about 1500 BCE, and somehow these outsiders, they have some secret tradition that goes directly back to Thutmose III, and that is what their tradition is based on. Now that's Henry Spence, and that's something totally different. So you got people taking an African knowledge, and they've spun it in all kind of different ways, and so it's our stuff, but it's been presented in ways that has little resemblance to the original. But I'm excited by the stonemasons, the original African stonemasons, not the secret order that came through Europe, and then we tend to embrace through them. So I say go back past them to the original. Same thing on college campuses. Most of us know about these Greek letter organs. What do you mean, Greek? What about an African brotherhood? That goes back to the old days. So to me, we're not going to get to the original unless we read in the original. But okay, like some of you are probably aware, if not, there's a book called Stolen Legacy. Now, who's the author of Stolen Legacy? Uh-oh, TK, he's smiling. Somebody got a
George Jackson. George Jackson.
Yeah.
George, not Jackson, but George. It starts with a J. Starts with a J. George James. George G.M. James. Yeah. So George G.M. James. Okay, he's the author of Stolen Legacy. He wrote it in 1954. It's a classic. So George G.M. James wrote Stolen Legacy, and his whole premise is how the Greeks stole African philosophy and African science, and now they're being given credit for it. And so he calls it Stolen Legacy. And so this is one of the great books. It's one of the most important books written in the 20th century, because George G.M. James shows that all the credit being given to Aristotle and Socrates, all it is not original. This is why when Socrates goes back to Greece, what happened to him? He was corrupting the youth by teaching what? Foreign gods. He had to drink the poison hemlock. What foreign gods? Talking about Amun and other African deities. So he had to commit suicide because he went and learned from Africa. But the point I'm making is that George G.M. James, he says the Greeks stole all of these things, and he's right. However, here's one thing to think about. George G.M. James, the great author, he does not read Medu Neter. So what George G.M. James is saying is the so-called mystery system. The Africans didn't call it a mystery system. It was a mystery to who? The foreigners. It was a mystery to the Greeks. So what George G.M. James is doing in his book, And the one criticism I would make, even though he makes a tremendous contribution, is he is presenting what he says is the ancient mystery system in Kemet, but he's looking at it through the eyes of the Greek foreigners who corrupted the system because they're presenting what they only knew. But George Jim James is not going past the foreigners' interpretation to the original to understand the system in more detail. That's why when people go with me to Kemet, you know what they ask? Hey, professor, man, I'm so excited to be here. I'm so excited. We're at the temple finally. Can you show me where it says, man, know thyself? And I laugh. I said, actually, you're not going to find it. So, Brother Odell, they're not going to find it. They said, there's no man know thyself. I said, that's a Greek corruption. So you will not find it on any temple. So anyway, my point is that it's a difference between the African original stonemasons and what later became Freemasonry. But the Greeks didn't invent it out of nothing. They took it and corrupted a lot of it. So it's our stuff that's repackaged by foreigners, is what I'm saying.
Okay,
Thank
so
you.
let's take a question from the chat box, and then we're going to go to Ben Pope after this. This is from Lonnie Wilson, back around 7 o'clock, 7:08. Would you please ask him to comment on an archaeological article I read a while back that said the first mathematician was a woman? They found a stone that had markings that were every 28 days, a menstrual cycle, the first known markings that exhibited mathematical equivalencies. They are in Africa, of course. Any comment to that?
Let me think here.
Do you know what the article Lonnie's talking about?
No, I don't.
I'll find it.
I don't know.
A few years ago. I'll find it, Manu.
Okay, you want to find it and then we'll bring it up? Or
okay.
If I can't find it,
right.
I'll look for it.
Okay, very good.
Okay, you know what I would say this about cycles. They clearly understood the cycles of the sun. They understood very clearly the cycle of the moon. So the moon was they tracked the cycle of the moon for rituals and ceremonies, and then they looked at the cycle of the sun and created a 365 and a quarter day in order to tell time, in order to and that time that they told was it helps them to know when to sow the seed, when to farm, when the Nile would overflow. So having an accurate calendar was very practical for them. And so that solar calendar goes back. Actually, you know when the solar calendar was created? The great scientist Sheikh Anta Diop from Senegal, he calculated that the solar calendar in Kemet was created in the year, he said 4236 BCE, 4,236 BCE, years ago, that is. So if you do, and then, back in the 80s, a lot of scholars said, you know what, Diop said it was 4236 plus or minus 4 years. So among African scholars, in African scholarship, because Diop calculated plus or minus 4 years, so we say that the first calendar, accurate solar calendar, was created in 4240 BCE. So that is 4240. So if you do the math, you will see certain flyers, emails, when people have events, you will see them, and they don't just use what are we in 2020? So you have to calculate 4240 plus 2020, and that's what the year is. So it'll be 6260, and you see that on some flyers. And to help people translate 6220, oh, I mean 2020. And when you see a flyer like that, you know that they are referring to the first accurate solar calendar in Kemet. So 6260 is when it was established, according to the great mathematician and multi-genius Sheikh Anta Diop. And so it's really tremendous knowledge. And, we can only cover so much, but I'll just make a comparison. Think about this, 4240 BCE, when was the first European solar calendar created? I'm glad you asked. It was created in the year 46 BCE. So let's do the math. You got 4240 more than 4,200 years ago, BCE versus 46 BCE. So that's a difference of more than 4,000 years. Why didn't the Europeans have an accurate solar calendar? Because they, in their ignorance and arrogance, they thought that the earth was the center of the universe. They had a geocentric point of view. They didn't know. And so, and that's why their calendar was out of whack. They had an outrageous calendar. And so think about our calendar now. You know, what are we in? We're in August. So how many days in August? 31. How many in September? 30. How many in February? That's a trick question. It could be 28, 29. But April, how many days? So, but their days they were all out of whack. They were never consistent. And when the calendar was way out of whack, they just add a month. And so when the calendar was established in the year 46 BCE by an African astronomer, the Romans under Julius Caesar, he goes to Cubit and asks the African astronomer Sosthenes to help us, help us to create an accurate calendar, because the Europeans did not tell time by the sun cycle. They told it by the moon cycle, and moon has an influence of the oceans, women's cycle, but it's not just women. The moon influenced men too. How many of us have heard of this idea of moon madness? Or let me translate: moon madness meaning a lunatic, a lunatic.
I know what happens in law enforcement. We know when it's a full moon, there's gonna be somebody doing something crazy out in the streets, and they teach us that. So.
Oh really?
Oh yeah. That I know it sounds silly, but funny, but law enforcement don't consider that as funny. They think on a full moon, be careful. It's a full moon tonight. There's gonna be some craziness happening, and it does happen.
That's good. No, that's good. I didn't know that. So full moon is gonna be a bunch of fools running around. So we know that the full moon. Oh, by the way, here's something else about the power of that full moon. We know about women's cycles, but men are influenced. Oh yes, we are. The oceans and tides are influenced. But the other thing is this: do you know when groups have when they want to do rituals and ceremonies? Full moon. You know why? Because we're going to be most receptive during the full moon. You want to get the most out of the ritual, the most out of the ceremony, full moon. And that's when a lot of groups do their prayer, their vision. No, I'm going to a natural place. If it's not the park, I don't the park sometime, but it's a body of water. Hey, you ever notice? You ever notice doing those like martial art films? You ever notice when Bruce Lee and others, when it's a tough issue and he's got some tough opponent, what do they do to think about the next move? He's at a stream. You ever notice? He's at a stream or a lake or a body of water for contemplation. But I'm saying this, during these cycles, like our solar return, the birthday, or even the full moon, that's the time to go to these natural places and really get the most out of, or do the prayer and the deep meditation, whatever it is, because we're going to get more out of it. And it's those kind of rhythms that we can attribute to those Africans in classical Africa who taught us what it meant to take full advantage of a knowledge of science.
Beautiful. Okay, Ben Pope.
Am I unmuted? Yeah. First of all, thank you for a lot of this information. I come from a scientific arena, and in the scientific arena, physicists are the hierarchy of scientists. And now I find out that physics really began in Greece. And so and mathematics really is the basis for physics, then it seems to me that Black people were the precursors of what we call physics, and the nuclear fission. All of that was done from mathematics. And interesting enough, at the University of California, there were no PhD degrees. You got your PhD in mathematics, and then you became a physicist. So it's interesting how the Western, we've been influenced to think one thing when actually it all began with Black folks years ago. That's just a comment I'm making, and you might want to speak to that.
Oh yeah, that's excellent. And it's interesting, like the math departments and And but that's one of the things that's a challenge, because there's so many of us have been separated from math, and so we don't have as many images of African scientists and mathematicians and physicists. That's why I mentioned a minute ago, one of the greatest, multi-geniuses in the 20th century is Sheikh Anta Diop, who was a physicist from Senegal and one of the greatest mathematicians. So this is why when Diop is translating the document, then this is a man with tremendous. He's not translating a mathematical document in Kemet just from the point of view of Egyptologists or something. No, he's translating it from a mathematician, from a physicist's point of view. So when all these people are we're trying to debate Diop, he'll switch hats from his linguistic insight, and he put on his physicist hat. When they try to challenge him there, he put on his mathematician's knowledge, and just so many different areas that. But I think that right now we have to teach more and more about African science, and like, for example, I've been challenging people at the college. You don't disrespect me and disrespect folks. You don't hire anybody. You don't know anybody, and that's why you don't have any diversity in your faculty ranks. Of course you don't know anybody, and you're not hiring anybody because you don't ask. But there's qualified African scientists. It's just that we have to think very differently, And like, I remember a long time ago in Oakland, there was a young guy. He could do theoretical math, very easy for him. And then as he got older, things happened. Now all of a sudden he's failing math classes. It's not his innate ability, it's the people around him, that didn't help him to move forward. He's got teachers that see him as just a nappy-headed boy and all this other kind of nonsense. And his mother, really didn't help him. And then when I saw him years later, he's failing math. He's failing history. And these are things that he loved to learn about. But I really think that's what it is. So I've challenged our college is bring in outside Black professionals, that you don't know about. No, you're not going to know about them because you're not a part of our community. Bring them in and have them do a talk, or even they might want employment. If they don't want employment, then they need to be in front of a large audience or go to classrooms or have a seminar for in these classes or majors, and but we just don't have enough people that are outsiders. Being African means being scientific, because that's what I've seen, and that's what we've seen tonight. Just even a small part of it. It's even the farmers. It's a scientific knowledge to know exactly when the sun reaches that point, we plant or we harvest. It's not just doing any old thing. So to me, everything is about it's about right order and right timing and knowing when those right cycles are. So I love to deal with science and all. That's why these people are surprised. Why would you be surprised? What do you think? A historian is just what? That's your historian is just dealing with history without all these fields are related for us in Africana Studies. There's no field that is not intertwined in some kind of way for us. And I just think we need to do a better job as a general community promoting scientists. So I know a lot of you have great backgrounds. And so I know you all do it with brother to brother, but it's the sharing of fields of expertise that needs to be even more widely shared, so that people in my position can say, you know what, there's a position opening up in biology, or I beat the guy down in engineering and made him agree to hire. You know what I mean? It's like that. So that's how I see it. We need to be more in these fields.
Wonderful. Okay, Leo Bazil, your question?
Yes, can you hear me?
Yes.
Yes.
I want to go back to something that TK brought up when he was asking you, was this a progressive accumulation of knowledge that allowed people to start from one point and then go and build something? And when you mentioned Ahmose, he was a scribe. What was the year that he was writing?
That was about 1600 BCE.
Okay, so 1600 BCE, he's writing something that he's copying something that somebody else had previously put down. Now, the nature of papyrus, like a paper or anything else, is going to deteriorate. So what he was copying off may have been done 1,000 years before. But the papyrus that represented that has since deteriorated, and his is still the only one here. So you look like that's the jump off point. And I say 1,000 years before because we started off with talking about the Old Kingdom at about 2,500 years, 2,500 BC. But that Nakata period was 4,000 years BC. And then before that was the Paleolithic period, which was 7,000. And I'm looking at my understanding of Chinese ceramics and how it goes back 5,000 years when they're looking at how they were glazing and doing the porcelain and everything that the Chinese are famous for. Can you tie in the things that we lawyers can draw inferences from, and that is some solid evidence, since we don't have the papyrus, but when you go back and look at the pottery, the sophistication of the pottery, and the kinds of grains that were found in these pieces of pottery when they did find the pottery will tell you that what kind of food these people were eating, what kind of bones were there, the kind of animals they had domesticated. But the sophistication of Chinese pottery was an indication that these were highly sophisticated people. These were not just hunter-gatherers and moving with the animals. These people had stationary positions where they could sit and have experts who could specialize in pottery and do that beautiful work. How much of that did we find in the Kushite situation in terms of the pottery and the things that they found as far back as 7,000 years ago in the Neolithic period?
Well, you know, it's a lot. When a lot of evidence from the Kushite period. So the heartland of ancient Kush is current day Sudan. So that's the rich archaeological area in Sudan where you find tons of pottery. And what's interesting about the pottery is that pottery is very specific to a culture. You know, the details, the shape, the colors, the designs put on. So pottery is very distinctive. And one of the things, ironically, you mentioned pottery. When I go to an archaeological site, sure, there are some massive monuments, temples and tombs and colossal columns and all of those other things, great temples, but we don't always see that. So what I look for, the telltale sign that a site was an important site that was occupied for a very long period of time, I look for the pot fragments, the pot shards, and that's a telltale sign. So when you see pot fragments everywhere, you know it was a rich archaeological site. But one of the things about Kush is that's what you find more of when we go back to the most ancient period. It's the pottery, the pot fragments, those artifacts, because there hasn't been a lot of detailed archaeological work done, or not only archaeological, but even ethnographic work. There hasn't been enough ethnographic work done in Sudan and South Sudan. So that's why when I was in South Sudan, when was this, a year and a half ago, they were excited because it's very rare that they would see a brother in South Sudan doing independent research, and they're humbly to learn from them, but also to share things with them that they're not familiar with. I mean, they normally see somebody who's white coming and normally attached to some, you know, research project or some government that doesn't necessarily have their research or their interest at heart. Or like some of the folks tell me is that they have issues with film crews who go in, they do a day of filming, 2 days of filming, and that becomes some spectacular documentary when they show it here. But it's to exploit them and not really to spend the time. And they, you know, brothers, they definitely told me that in more than one place. Definitely the Morsi told me that. But pottery is one of those distinctive things that that distinguish a culture. But I've said about the Nile Valley this, one thing about that whole region of Kush and Nubia and Kemet, when it comes to pottery, it's a cultural complex that is difficult to tell the pottery from one of those groups or another. Like folks say, you know, the most common pottery when it goes back, Brother Leo, to that older period, it's the black top pottery. It's the pottery that has like this, they burn it, so it's the top is black. And it's, wow, is that Kemet? Is it Kush? Don't know. Very difficult because it's one cultural complex where there's intermingling. But what does the foreigner say? When the foreigner doesn't like the fact that Kemet in the north is influenced by those in the south, the Kushites, you know they call it cultural entanglement. Some negative kind of, what do you mean entanglement? Instead of cultural integration, they call it culture. So that's what I said. So that's why I was telling some of the colleagues. I said, you see, this is why I don't respect this kind of nonsense. It's not honest scholarship. It's somebody that has a preconceived notion, negative ideas that nothing could have come from the South. Well, why not? Why couldn't it have come from the South? You know, I mean, entanglement. You know, the Southerners are not copying anybody. This is a cultural complex that's linked and united. And the Nile River, it links these groups, and the pottery clearly demonstrates that. So the work has to be done. And that's why, you know what I'm going to do, brothers? This is the fall. So in the spring, guess what I'm able to do in the spring? And those of you in academia, you know the importance of this. In the spring, guess what I can apply for? Sabbatical. And I'm going on 1 year sabbatical. I ain't on one semester, a whole year. Actually, I'm counting all the months. It ain't 1 year. It's 15, 16 months. So I can do what? Go back in the field, and I don't have to worry about the academic calendar. So then I can provide even more evidence, even more ammunition to that question about the early days, because I'm excited to go back and document more.
Well, fantastic, Professor Manu, and in respect of your time, we're already 15 minutes over, but obviously it's been fabulous. We really appreciate you and your effort and your education and presenting it to us in a very succinct manner. So thank you for that. Why don't we pray out? Let's pray out, and then if you want to hang around and everybody wants to talk a little bit, that's fine. But who would like to pray us out? All right, Reggie Pate, unmute your phone there and jump on it. Go for it.
Oh, forgive my hair. Okay. Merciful Father, we thank you for another week and another session. We thank you for the families that are here. We thank you for all that you've done for us this week. We ask you to keep us safe, keep us healthy, bring us back next week for more information, for more knowledge of ourselves. We thank you for our teacher. We ask you to help him in all that he does in his preparing for our class. We thank you again for our lives, our health. We ask you to bless us all. Bring us back next week, next Tuesday and Thursday, in your son, Yeshua HaMashiach, Jesus' name. Amen.
Amen. Amen. Thank you. Thank you, Reggie. All righty.